Let me introduce myself. So my name is Yi Hong. I'm from Department of Electrical and Computer Systems. So I'm a senior lecturer there, and here's my office. I'm in room 224, building 72. I'm also the coordinator of this unit. So basically, today's lecture, it's the third week of our lecture. So basically, our lecture divided into two parts, part A and part B. And part A is majority, we are focusing on basic programming skill, okay? And part B will be some mathematical part of programming. So I'm going to cover the rest of part A, and then part B will be another lecture. So MATLAB is basically the more you practice, the better. No other tricks, okay? So, for example, you listen to the lecture, you may think you understand, but when you do your own lab, you may understand much deeper. Okay, it's like a musician. The more you practice, the better. Okay? Today, our first topic, we're talking about M files. So I think last week was the first week of your lab. So majority of the students have been able to create it, MATLAB M file, right? Have you tried? Okay. So nevertheless, for some people who haven't done this, basically the first 10 slides all about how to create and run an M file. I thought if we go through slides, it's going to be a bit dry. So instead, I'm just demonstrate you how we create an M file here. Okay? So here is for my teaching purpose. So I partitioned the entire window to this is editor. Okay, where you create M file is here, and here is a command window. Okay, workspace and command history. Basically, these two we don't use much. So majority of the time we either use command window or this editor. So of course, for basic simple computation, what you can do is just type in the command window. Okay. So this is a very quick. Normally, for quick thing, you type in the command window. For as the requirement of the programming increase, so you need to make a longer program. Okay, what normally we do is to create M file, or we call M script. So basically, you go into the editor, and here. So there is a white button. It's called a new script. Of course, you can also start from the first column here and say new. But what I prefer to do is easier is just to type in this. Click the white button here. Okay. So what you can do, for example, you say is from minus pi with the step 0.1 to pi. This to tell you create a vector from minus pi to pi with the step 0.1. Okay? And then we see y. Let's compute sine of a. Okay? And then this we will start later. I just for your quick demonstration purpose. So I plot A versus Y. Okay? So this I create a new script and I type in a few lines of MATLAB code. And then you save it by click here. So for example, I'll just save as a desktop test. So when you save it, it automatically pop out this window, ask you file name. So you just type in the file name that you want. Because the save as type, there is a default .m. So no matter which file name you type in, it's going to create this file name .m. Okay? So you save it. And then when you run it, okay, so you can directly click this green button here. Okay? So it asks you change the working folder. So you say yes, changing folder. So it directly plot the whole thing. Okay. So this is the how do we create a M file, save it, and run it. So instead of hit this button, you can also press F5. Okay. So this is the how to create MATLAB file, how to run it, and how to show the result. And so this is pretty much the first part of what we're going to introduce. This is a MATLAB M file. And in your lab and in many in the later assignments, you're going to create have plenty of chance to practice how to create M file. So let me skip these few slides as what we talked about already. Now, so when we run this M file, how does M file work? So basically, you have a few lines of MATLAB codes. So this M file will go through each of lines sequentially. So what happens if you made a mistake? Okay? So when you make a mistake, so MATLAB will not run these mistaken lines. So it will exit from here. And also in the same time, it will print out in the command window that you are making a mistake. Okay? Something like this. Okay? So now, for example, I'm making a mistake here. Okay? For example, I accidentally pressed the Y dot. So now, when you save and run, so MATLAB will automatically pop out this red text to show you some errors. So sometimes they even indicate which line, which column. So line 2, and it's point out this. Okay, so you correct them. So this is the M. Sorry, this is how M file run and fail. Okay, so pretty much is talking about M file. Now we move on. Another topic is called good programming skill. So good programming skill divides into two perspectives. So when you write a MATLAB codes, the first perspective that you want to make this code easily understandable by other people. Because imagine you're working in an engineering team and maybe someone made a MATLAB code and someone passed to you, okay? And he quit this engineering team and you're going to follow up his work. So what you expect is his MATLAB codes for you is going to be very easily understand. So this is the first point, why we need to make a good programming. And second is make it reusable. Make it reusable means you get a MATLAB code, okay? This code must be efficient and smart, so you can change just as least as possible to make these MATLAB codes also applicable for other things, okay? So this is 2 points. Now we talk about the first point, how to make the MATLAB codes understandable for other people, also for yourself, because you could make a MATLAB code a few months ago, and then you go back and don't remember what you have made. Okay? So what we're going to do is documentation. Or here we call it comments. So comments, how do we do it? I'm going to demonstrate you here. So for example, we're going back to this MATLAB code that we created. Okay? So comments is normally start with the percentage sign. With percentage sign and followed a plain English text to describe what you're doing. For example, you say plot sine wave. Okay? So this is to explain what the MATLAB code is about. Okay? Why we're doing this MATLAB codes. So this is called a starting of comment. Okay? The percentage sign have another purpose. So normally in MATLAB, for example, here, you want to hide this line. You don't want MATLAB to run over this line. But instead, you want MATLAB not to read this line. So what you can do is you put a percentage in front. So it turns, the color turns into green. That means MATLAB will not read this line. So normally you do that is temporarily you want to hide some MATLAB lines. You don't want MATLAB to read. But then you don't want to delete it because it could, later you could use this. So you can unhide it. Just remove that percentage sign. Okay? So this is commenting. Okay? So basic commenting is to explain this MATLAB code. It's very up to you where to put this commenting. Okay? So sometimes if MATLAB code is quite obvious, it's not necessary to put. But normally, when MATLAB codes are complicated and you want other people to understand your MATLAB codes, you put this percentage sign with plain English text to describe the whole thing. And as I said, for some commenting, you can put either on top of the MATLAB sentence line, or you can put beside it. You can also put right after. For example, here, you can put sine wave. So it's really up to you, okay? And also you can put one line for the entire block, or you can put some explanation for a small portion of the block. It depends how you want to make other people understand your MATLAB codes. So this is comments on your MATLAB codes. And also normally when you're doing M file, we also need to do the self-documentation. So self-documentation means, let me show you here. So when you make a MATLAB code, for example, in your lab or in when you deal with assignment, so normally you say made by who. For example, written by, and ID is blah blah. Okay, and this is author, and then you put a date. So put a time. What's the date of today? Sorry, 18 March 2014. So and then the last line can be what's the MATLAB code's about. Okay. So this a few lines is called self-documentation. This is also for clean MATLAB codes. And also apart from that, for each M file, normally we put 3 lines extra. We put a CLC. Let's see, clear all. okay, close all, and CLC. At the beginning of MATLAB codes. So this 3 line is to tell you clear all is to clear all the saved database. Maybe you pop in a computer that some other students left their MATLAB there. So you don't want their database influence on yours. So clear all the saved data in that computer. And close all, okay? Close all the everything, the data. And the CLC is clear the command window. For example, here I can put CLC and cleared everything. Okay, these 3 lines is actually tell you now I cleared everything. I'm ready. I'm ready to make these MATLAB codes. So normally we put these 3 simple lines at the beginning of MATLAB codes. Okay. So we talk about the documentation. Now, this simply is some MATLAB codes without documentation and with documentation. Okay, this is a self-documentation, and followed by each block, there's some documentation telling you what is this MATLAB code about. So it's very easier to understand. Okay. Now, the second perspective of good programming is reusable code. So you make the codes reusable. Why shall we make codes reusable? Because you don't want to get so many repeated parts in your MATLAB codes. If you find any repeated part, then you're going to make it. Normally what we do, that repeated part, in the next lecture I'm going to talk about this, is you make a MATLAB function. You call this function instead of repeating every time of this computation. So this is something we talk about next class. And reusable code basically is to say you make a MATLAB code simple and easy for other people to change. Because you get a MATLAB code, you want to change as least as possible so it adapts to all possible applications. That's what reusability means. Okay, so now we see an example. So this example is a simple example for reusability. So now I give you a line. So plot this versus that. Okay. So now you observe this line of MATLAB code. Do you see any repetition pattern here? Yeah, exactly. So this one, -5 to 5, and you observe it's also from here. It's repeated 3 times. So assuming you are saying, let X represent this. So you find X is here, X is here. So what is this part about? This part is going to be -2 times X power of 2 plus 2 multiply X plus 5. Okay? So can we make it better, this MATLAB codes? There's nothing wrong with this line, okay? So it's just imagine if your boss asks you, I don't want observe from -5 to 5, I want -10 to 10. So you're going to replace -10 to 10 here and here and here. You change 3 times. Okay? Make a modification. So now I'm saying instead of doing that, instead of write one line, I'm assign -5 to 5 to the variable X. Okay? And then I assign Y equals it's actually this part, okay? So then plot X versus Y. It's the same thing. These 3 lines have the same outcome with this one line. But we say this is more reusable. Why? Because once times you want to change from -5 to 5 to -10 to 10, you just change it once. And here you're going to change 3 times. Okay? So then we say this MATLAB code is more reusable because you modify very little, okay, compared to the previous case. Of course, these both are correct. This basically ends our M file and good programming skills. Okay, so the first part is very easy, and the second part we're gonna talk about a few building function, which is very important. Normally use it in the in your lab. So first we talk about pause. Pause means if you put pause in your simulation, in your MATLAB codes. So MATLAB will run until that pause, and then we'll stop there. Until you press any key from your keyboard, it will go on until the end of the MATLAB file. So now I'm going to show you here. For example, I put pause here. Okay? So what MATLAB will do is you go through this line, this line, this line, until compute Y. And then you read pause. So MATLAB will pause here. We'll stop there and wait for your order. So what you're going to do is you press any key in your keyboard, and then it will continue, plot the whole thing. It will go to the next command line and then go on. So let's do this. So now it's pause. Actually, it's remind you here at the bottom. It's a pause. Press any key. Okay. So I press space. So and then it's go on. And the second built-in function is, so if you don't like pause, okay, instead you want control the stopping time, you say pause, brackets 3 means pause for 3 seconds, and then go on. Okay, now I press here. So you wait for 3 seconds and then go on. Okay, this is a 2 built-in function, pause and pause the control time. Okay, so the next built-in function is DISP, means display. So display can display value and text. So when you display value, for example, I let A is 3, assign 3 to A, and I display A. Okay, so that means you are display the value of this variable A. So it's going to print out 3. However, if you want to display a text, okay, so normally you put text. If you want to display text, you must put quotes around the text. Okay, so this I can show you. Here, let's remove pause. So now let me see B equals 3. Okay, then I say display variable B. Okay, so I don't want plot any longer, so I can hide it, this one. Okay, so it displays the value. Okay, however here now I want, for example, I don't want display this value. I want display, for example, a text ABC. Okay, so if you write this way, it is wrong. Okay, you must put single quotes around this text. Then this is what you display. Okay, this is text. This is something about DISP, display. And the next built-in function is input. So input followed by a text. This whole thing is to telling you, first MATLAB will print out this text. And then wait for you to input a value. For example, you input 3. So then MATLAB will assign this 3 to A. Who switched off? Did you switch off? Thank you. So let me demonstrate this. So for example, I said B assigned as input. So input will be, for example, I say input a number. So when we run this MATLAB, so you see it prints out this text, and so waiting for you to input a number. So for example, I input 10. So then they assign this 10 to the variable B. So now I see what's the number of B. B is 10. Okay, this is. Is that possible for you to turn on the lights? Thank you. Just don't press it. So this is built-in function input. And the last built-in function is a bit tricky. Echo is called echo. What is this echo about? Is actually it's actually two pairs, one pair of command. So when you say echo, you normally will say echo on. So if you say echo on, then you must have echo off. So this echo on, echo off, what is telling you about is the MATLAB, when they say echo on, that means MATLAB, what MATLAB going to do is print out this line in text. Okay, at the meantime, it's also run this line. And then when they say echo off, so stop this printing. Okay, so let's run this MATLAB code. So you see, it prints out the entire line. This entire line is between echo on and echo off. And also, it executes this line. So input a number, let's say 10, and then they assign B, 10 to B, okay? This is echo on, echo off. Normally, we don't use this. It's just very special built-in function. So now we see an example. This example is to give you a triangle. So imagine you have an input, we say X. You have another input, we say Y. Ask you to compute the length of the third side. So which is very easy computation is X squared plus Y squared. Take a square root. This is the length. This is the result. Okay? So now we are showing how to make this MATLAB codes, combining all MATLAB function, the function I was talking about. So instead, I'm showing you here. So this is the MATLAB codes that I'm going to demonstrate you. So this MATLAB codes, first line, display, followed by an entire line of text with a single quote. So you understand what it's about. You print out this line. And then the second line is to ask you input followed by text. So what MATLAB will do is print out this line and wait for you to input a number. For example, you input 3. So MATLAB will assign 3 to this variable, adjacent. And then same thing happened to the second input. For example, you input 4, it assigned to opposite. Okay? And then what this code is telling you about is echo on, echo off. Exactly what I just introduced is when MATLAB saw this, MATLAB will print out this entire line in text. Also, at the same time, doing this computation. So adjacent, for example, is 3, opposite is 4, square root is just 5. And then you assign 5 to this variable. Okay? and then display this line, pause for 3 seconds, and display this line. And we notice the last line of MATLAB codes is displayed without quotes, okay, single quotes. That means you display the value of this variable, not text. Let's run this MATLAB codes. So sorry, let me break it first. I don't like it because of I want to make it just make it a bit clean. Okay. So you see, this is basically print out of the first display, and now MATLAB is waiting for you to input a number. So you input 3. So actually, you input 3, and this 3 will be assigned to this variable, adjacent. And then MATLAB move to next line, line 13, here. Okay? So you will see, as you input the other side, the length, I input 4. So 4 will be assigned to this variable. And in fact, you will see that when echo on, echo off, here, echo on, echo off, in between this whole line was printed out here. Okay? And also print out the echo off followed. Okay? And then display the whole thing, wait for 3 seconds, print out this line, which is here, and then display the final result. So this is an example just to let you get familiar with all this MATLAB building function. And in fact, this MATLAB codes that I'm demonstrating is also available on, in Moodle in the lecture slides, that session. So you can, if you want to play, you can download. So now we see an example. So this example is very easy. This example is, I give you 1 minute to read. Okay? Sorry. Okay, so let me briefly summarize what we're going to do here. So this story is about the NASA spacecraft. There's 2 spacecraft was sent to the universe to explore. So the spacecraft was powered by the nuclear reactor that will decay gradually as time goes on. So it was 470 watts, and now it's 335 watts. Okay? So the spacecraft, the first one, is traveling in this speed. It's 3.5 astronomical units per year. And the spacecraft 2 is travel in this speed. Okay? And their weights, they have equal weights, is given here. Now, given all these conditions, ask you to calculate the acceleration that the 335 watts generator can produce in each spacecraft. Okay? So now, we summarize the math that we need to do. So this is basic high school physics. So this work is just a force multiply the distance. So power is work divided by time. So it's basically substitute this in here. So what you get is force multiply distance divided by time. So this is basically velocity here. Okay? So what is force? Force is mass multiply acceleration. So now we're given this equation. Okay? And now we go back. We have mass here. Okay? This is mass. And this is a velocity 1, a velocity 2 for different spacecraft. And we have a power here. Okay? So that means you have power here, you have mass here, and you have velocity here. And this acceleration is what you want to calculate. So it's simply acceleration is the power divided by mass multiply the velocity. Okay? So follow this equation. Now we formulate what is input, what is output in MATLAB. This is a preparation for MATLAB programming. So what is input? You have mass is given, power is given, okay? Velocity is given. And the output, this is input and output. Output is what we're gonna do is to calculate acceleration for different for two spacecraft. So this is the equation that we're gonna do. And so before the computation, we need to change the unit. So astronomical unit per year we're gonna change to meters per second. So astronomical unit is actually the distance between the Earth and the Sun. So it's given here, okay? And the year you're gonna change to seconds. So each year, this day, 365 days. Every day you have 24 hours, and every hour is 3,600 seconds. So this is changing unit, okay? After you changing unit, you just plug in this equation. You have power, you have velocity, you have mass, and then you get what this MATLAB code asks you to do. Okay? So now we have everything. We have input, we have output, we have math. Okay? Now we are going to write MATLAB codes. And before we writing MATLAB codes, normally we make a pseudocode. Pseudocode is not a MATLAB code. It's the step you're going to do in MATLAB codes. So, for example, in this case, we make 4 steps. First, declare input. Second, declare velocity. And then changing unit. Okay? And then calculate acceleration. This is basically 4 steps of your MATLAB codes. So what you're going to do is you copy these pseudocodes and you paste to the new script you created, and then put a comments in front of each pseudocode. So then this pseudocode turns into comments. So follow each comments. You just put all variable in, do a few computation. So does it finish this MATLAB codes? No, it haven't. Okay? So what we're going to do is put these 3 lines, say I'm ready. Okay? Also, in front of, before this, we put a self-documentation. This will make you a complete MATLAB codes. And the final step is just check your solution. So today's lecture is pretty much, that's the content. It's very easy today. And on Friday, we're going to talk about MATLAB function, which is a very, very important topic, and it's a bit more complicated. So, okay, I'll see you on Friday.